everyone, welcome back to Code with Us YouTube channel, and we are with one more web series of operating system. So today let's see what is process, and the next topic of this web series is process. So what actually the process and what are the things to be learned in this process concept? Let's see. First of all, which is an operating system which executes a variety of programs in the terms of batch system, which is called jobs, and time shared systems like user programs or tasks. In this process, which is a program in execution or process execution must progress in a sequential fashion, is nothing but a process. A process is a program which is in execution. Process execution must progress in a sequential fashion is nothing but process. Multiple parts are there. The program code, also called text section, current activity including program counter, processor registers. Stack contains temporary data, function parameters, return addresses, and local variables. Data section containing global variables. Heap contains memory containing memory dynamically allocated during runtime. And coming to the next slide, process in memory. So how the process will be there in the memory? We'll be having the stack, we'll be having heap memory and data and text. So from max at the max, there will be the stack position, and each and every process comes into the stack, and it will be allocated into this process in the memory using this. This is the block where the process will be stored in the memory. And coming to the next slide. Actually, the program is passive entity stored in a disk, which is an executable file. Process is active and program is passive. Program becomes process when executable file loaded into memory. Execution of program started via GUI mouse clicks, command line entry of its names. One program can be several processes. Consider multiple users executing the same program.
Hello all, and coming to the next slide. Now we will discuss about the types of states in process. Like there are a lot of states in the process, so we will discuss those states. What are the types of states are there? So as a process execute, it changes the state. So first one is the new. So new means the process is being created, and the next one is running. So the instructions are being executed. And the third one is waiting. The process is waiting for some event to occur. And the fourth one is the ready. So the process is waiting to be assigned to a processor. And the final one, it is the terminated, that the process has finished the execution. So these are the types of process states. And this is the diagram of the process state, how it will work. Like from new, it will go to the ready, it means admitted. Like, and when it is ready, when running, if another process is came, then it is interrupt. So if it is running, so this is from scheduler dispatch, from waiting to ready. So this is the event wait and the event completion. So if running from exit, while running, after running, if it get exited, terminated, this means the exit. So these diagrams explains about the process state. And the next one, process control block, PCB. What is process control block? Let's discuss now. So information associated with each process, like also called a task control block also. So it is also called a task control block. So it controls the processes which will occur. So we will discuss what are the things in PCB. First one is the process state. So in diagram, the first one is the process state. So it means the process state is running or waiting, etc. And the next one is the program counter. Program counter, it location of instruction to next execute. And the register, so CPU register, it contains of all process centric registers and the CPU scheduling information. It means the priority scheduling queue pointers and the memory management information. It means memory allocated to the process, like how much memory allocated to the process, so it will know. And accounting information. It means CPU used a clock time elapsed since the start at the time limits. And the final one is the IO status information. The IO device is allocated to process like a list of open files. So this is about the PCB. And next one we will discuss about the CPU switch from process to process, like how it will switch from process to process. See how CPU will switch the process. So there are some steps involved. So like for the we will discuss about the steps involved in context switching. This is nothing but the context switching. So the process of context switching, it involves a number of steps. So this is the diagram depicts the process of context switching between the two processes like P0 and P1. Let's take an example for P0 process P0 and the process P1. So in this figure, we can see that initially the process P0, like this one, it is in the running state, and the process P1 is in the ready state. Now, when some interruption occurs, then you have to switch the process P0 from running to the ready. So state after saving the context, like from after saving the context, and the process P1 from ready to running state. So the following steps will be performed. So for this we have five steps to we have to follow those 5 steps. Let's discuss the first one. So firstly, the context of the process P0 means this one, that is the process present in the running state. The P0 is in the running state now at present, will be saved in the PCB process control block of process P0. This means the PCB not. Thus it will be saved in this part. So that is PCB not. So now the second step is, now you have to move the PCB one to the relevant queue, like PCB not into the relevant queue, that is ready queue, like means IO queue, waiting queue, etc. So we can and the third one is, from the ready state select the new process. So from here P1 it is in the ready state, so we have to select this P1 process to the new process that is to be executed. So that is the process P1. So now update the PCB, like mean process control block of process P1. So now we have to update the PCB1. So the process also PCB1 by setting the process state to running. So if the process P1 was earlier executed by the CPU, then you can get the position of last executed instruction, so that you can resume the execution of a P1. So, and the final one is, so similarly, if you want to execute the process P0 again, so if you want to execute this P0 again, so then you have to follow the same step, like we have to save, we have, so as a earlier step what we have to do, again we have to follow the same steps, like from save to into PCB1 if interrupt our system calls. So this means, so for context switching to happen, there are two processors at least required. Like we have to perform this process, at least we have to require two processes. So the time involved in this context switching of one process by other is called the context switching time. So that we call it as a context switching time. So this is what about the CPU, how the CPU can switch from process to process. So this diagram, these are the steps we have to follow. So and the final one is threads. Threads mean like, so four processes has a single thread of execution, and consider having multiple program counters per process. The multiple locations can execute at once. It means the multiple threads of control. The threads so must then have storage for thread details and multiple program counters in PCB. So this is all about the today's topic. So thank you so much, and please subscribe to the Code with Us channel, and do like and share. Please subscribe. Thank you so much.